Module 3, Part 2, Elimination Guided. In this section, what we're hoping to do is multiply something here on the left that will result in either the x's canceling each other or the y's canceling each other. And so what we're going to do is figure out a number. Well, if we look at the x's, for instance, we could get both of those to 15. And ideally, we'd have something like 15x, negative 15x, and then positive 15x, because what we want is for one of those variables, either the x's or y's, to cancel. And if we had on the right here, negative 15x and positive 15x, those two would cancel each other out. They'd eliminate. So another option we could have is, if we were looking at the y's, negative 7y, positive 4y, we could get both of those to 28. You know, if you had negative 28 up top, positive 28y on bottom, both of those would cancel also. So you want the top number and the bottom number to be the same but different signs. So if we were, let's say we were trying to get the x's to eliminate, we'd get the top to negative 15, the bottom to positive 15. So in order to do that, we'd multiply we'd multiply 5 on the bottom and 3 on the top. And that would give us, and by the way, they're going to have zeros in both of those boxes below. You can go ahead and delete those. And you'll be entering in the 3 and the 5. If we wanted to get the y's to eliminate instead, we'd multiply, we'd get this to 28, and we'd multiply it by 4, so it'd be negative 28. We'd multiply this by 7, so it'd be positive 28. When you do that, when you figure out what those numbers are going to be, the software will rewrite the equation, so it'll take 3 times everything here, 5 times everything here, and then you'll see how they eliminate. That'll probably make more sense once you're in the software in Deltamath and you see what happens when you enter in the 3 on the side, 3 on the side, and then the 5. You'll have a separate set of equations that have the new numbers on them. The second set of problems, elimination strategy. A variable needs to be eliminated to solve the system. Choose the first step. So we're not actually going to go all the way through these. We're just going to choose whatever that first step is. Here, as they are, the system, the x's almost cancel. The y's don't. But if the signs were different, negative 5, and if this was positive 5, then they would cancel. So what we're going to need to do is, if we're choosing here between the options that we've got, add to eliminate x. If you add, really what that means is you're keeping the signs the same. And then just adding what's there. But if we added the x's, they wouldn't cancel. We'd end up with negative 10x. If we added the y's, we'd end up with 8y if we added. As far as subtracting goes, we're going to change all the signs of the second equation. Change all the signs of the second equation. So, which is actually what we would want to do. If we subtract this second equation, then the negative 5x would turn into positive 5x, and then our x's would cancel. So realizing that means that we're either going to choose subtract to eliminate x, subtract to eliminate y, but we're going to choose eliminate x, because if we subtract, the second equation signs all change. The y's don't eliminate, but the x's would. So basically we'd be subtracting the second equation, we'd have positive 5x, and we would eliminate the x's. So on this one, we're just going to choose subtract to eliminate x. Another example like that, here we've got 6x plus 4y equals negative 80, and then negative 6 plus 8y equals negative 16. We want either we're trying to eliminate, so either the y's eliminate or the x's eliminate. If we leave everything exactly like it is, the x's eliminate. So we can just add these. We don't have to subtract and change the signs. We can just leave everything the same, add them, and the x's eliminate. So not a whole lot to do on that one. Next, we'll actually run through this process. 5x minus 2y equals 12. 6x plus 2y equals 32. So in some cases, we'll need to adjust the equations a bit. But on this one, hopefully you notice that our y's, as they are, cancel out. So we're going to combine these equations. On the left, we've got 11x when we add them. Y's are gone. On the right, we've got 44. Divide 11 to get x by itself, and we end up with x equals 4. We do still need to find y. So what we're going to do is we're going to substitute 11 now for x, and then we'll solve for y. So we've got 5x minus 2y equals 12. X we know now is 4. So we've got 5 times 4, which is 20, minus 2y equals 12. Subtract 20. And we've got negative 2y equals negative 8. Divide negative 2. And we get y equals positive 4. So our eventual solution is x is 4, y is 4. And that's where these two equations would intersect if we drew them as lines. Next example, basically the same thing, only x's aren't going to cancel, y's aren't going to cancel, but they almost do. So we can get the y's to cancel as long as we make one of these positive. So in order to make that negative 7 positive, we're going to multiply negative 1. And we have to do that times the whole equation. So I'm going to leave the top the same. I'm just going to rewrite everything. Top equation, negative 7x minus 7y equals 28. Not doing anything with that one. But the bottom one, we're multiplying negative 1 through so that the y, the negative 7 in front of it changes to positive 7. So now we've got, I'll do a new equation in red. We've got negative 2x, positive 7y, and then we've got negative 1. Now we can add our equations. Our y's cancel out. Bring down the equals. On the left, negative 7x, negative 2x is negative 9x. On the right, 28 minus 1 is 27. Divide negative 9 to get x by itself, and we end up with x equals negative 3. Still have to find y. You can use any of these equations, by the way. I'm just going to use the top one. Negative 7x minus 7y equals 28. We know now x is negative 3. So negative 3 times negative 7 is 21. Minus 7y equals 28. Subtract 21, so we've got negative 7y equals 7. Divide negative 7. And y equals negative 1. So ultimately, our answer, x is negative 3 and y is negative 1. Our sixth example, elimination level 2. 4x minus y equals 11. 2x minus 4y equals negative 26. As it is, the x's do not cancel. The y's do not cancel. So it's going to be up to us to get something to eliminate. The x's, we could get them to eliminate if we had something like 4x. And if we could get the 2 to negative 4x, then those two would cancel out. And we can do that if we take this bottom equation. We want to get it to negative 4, so we need to take it times negative 2. You could also get the y's to cancel. You just have to figure out what number they both can get to. You could get both of these to 4. You just need to, since this one's already negative 4, you could make the top positive 4 by multiplying negative 4. So I'm going to rewrite these. The top one we're not doing anything to. 4x minus y equals 11. On the bottom now, multiplying negative 2 through. So negative 2 times 2 is negative 4x. Negative 2 times negative 4, positive 8y. And then negative 2 times negative 26 is 52. Now we can add them. The x's cancel out. Negative, this is 1y, by the way. So negative 1y, positive 8 gives us 7y. On the right, 63. And we're adding the 11 and the 52, adding the y's. Divide 7 to get the y by itself, and y equals 9. Still need to find x. I'm going to go ahead and use the top equation. 4x minus y equals 11. We know y is 9 now. Add 9 on both sides. And we're left with 4x on the left, on the right, 20. Divide 4 and x equals 5. So ultimately, x first, so make sure you put the 5 in and then the 9. Number 7, negative 2x minus 5y equals negative 12. 10x minus 4y equals 2. Here, if we wanted to get rid of the x's, we could get both of those to 10. Just to preview, 10x and negative 10x, those would cancel out. So if we can get one of them to negative 10x, the bottom one is already 10x. So if we can get the top one to negative 10x, then we can get the x's to cancel. I'm going to go ahead and do that. I'm going to take the top one. If we want to get it to negative 10x, we're going to take it times 5. 5 times negative 2 would give us that negative 10. Okay. Make sure you distribute that 5 all the way through. 5 times negative 2, 5 times negative 5, 5 times negative 12. And then the bottom one we're not doing anything to. 10x minus 4y equals 2. X's cancel now. Got negative 29. Y equals negative 58. Divide divide negative 29, and y equals 2. Find x. We can use any of these equations. I'm going to use the top one, negative 2x minus 5y equals negative 12. Negative 2x minus, we know y is 2 now. So we've got negative 2x minus 10 equals negative 12. Add 10. Negative 2x on the left equals negative 2. Divide negative 2. And x equals positive 1. Ultimately, we've got an ordered pair for an answer. X goes first, y goes second. All right, level 3. Nothing really new here, basically just the same ideas. But I thought I'd give you an example for this one anyway. So we want the x's to cancel or the y's to cancel to eliminate. You could get both of the x's to 8, make one negative, one positive. Or the y's are already at 5. You just have to make sure one of them is positive and one of them is negative. And we can do that if we just take the top equation times negative 1. And that'll make our y there positive. So I'm going to rewrite both of these. Top equation, we're multiplying negative 1, so we've got 8x plus now 5y. And then negative 1 times negative 13 is positive 13. Okay, and then the bottom equation we're not doing anything to yet. Y's cancel. 8x minus 4x leaves us with 4x. On the right, adding those, 13 plus 11 is 24. Divide 4. X equals 6. Okay, so find y. Going to use the top equation. We know x is 6. So replace x. Okay, so our ultimate answer, x equals 6 and y is negative 7. Point solving systems of inequalities. Y is less than 1/5 x plus 2, and y is less than negative 2x plus 2. Basically, all we're going to do is substitute in these values. Remember that the first one is x, the second one is y. So we're going to plug these in for x and for y and see if we get something that works. So let's start with the first pair. Going to put that in for x and y, and we'll see if this works. So we're going to start with the first one. I'll do this over here. Y is less than 1/5, and let me replace the y. Instead of y, we're saying negative 9. That's our x that's listed there, or our y that's listed there, rather. And then 1/5 times 5, replacing x, plus 2. Here, if you're multiplying 5 and you've got 5 on the bottom, those two cancel out. And we're left with negative 9 is less than 1 plus 2. Negative 9 is less than 3. Which is true. Negative 9 is less than 3. And then we just need to plug this pair into the second inequality and see if we get it true also. If it's true for both of them, then we can go ahead and stop right there and use that one. So true for the first equation. We'll see if it's true for the second one. Y, negative 9, is less than negative 2 times x, which we're saying is 5, plus 2. Negative 9 is less than 10, or negative 10 rather, plus 2. Negative 9 is less than negative 8, which again is true. So that one, if it wasn't true for both of them, we'd go on, we'd try the negative 5 and 8, we'd try the 5, negative 7, in the same manner that we just did that one. And the last thing that we'll look at, linear inequality systems. We're doing it graphically. And then we'll also state the coordinates of a point in the solution set. So a couple things on this one that I want to point out. Anytime you have one of these inequality symbols that's got a line on the bottom of it, we're saying less than or equal to, greater than or equal to. These are going to be solid graphs. And anytime we have, like the bottom inequality, we've got less than or greater than, no equal underneath those inequalities. These are going to be dashed lines. So you're going to have to make that determination when you're graphing these. Is it solid? Is it dashed? Pretty simple. Just have to look at that inequality symbol. And then the next thing that we'll do is graph these. And you should have a little bit of experience with graphing because we did that in well, earlier in Module 3. But we're going to start at this point here. We're going to start at this point here. So negative 4. Going to put a dot there. And then we're going to rise, run. So negative 2 over 1, that's our rise, and that's our run. So we're going to go down 2, and then over 1. And that's our second dot. Remember, this is a solid line. So it should look just like that. And then one other thing, we're still dealing with the top equation, but it reads y is less. It actually says less than or equal to, but y is less. So what we're going to do is we're going to shade below. So that line that we just made, I'll do this in highlighter. We're going to shade below that line. Okay, and then we're going to make the other equation, or the other inequality. And we've got 2 that we're going to start with. 1, 2. So we'll put a dot there, and then the number in front of x is going to tell us our slope, our rise, run. So we've got 1 there. 1 is really 1 over 1. So our rise is 1, our run is 1. So from that 2 point, you're going to go up 1 and then over 1. So that'd be your second point. Do this in green. So you should have a graph that looks something like that. And this one reads y is less also. So this is the green line. We're going to shade below that. And then we just want to pick, so we've got some areas of this where there's multiple overlapping or there's multiple highlighting. So this area here, I don't know if you guys can see this. This area in here is overlap. It's shaded twice. So we shaded below, we shaded below, and then this area in here is where it's overlapped. So all you're going to need to do for the second part, the coordinates, is just pick a point in here. So you'll be able to see on your graph what the grid is. Maybe that's -3, -5. I'm just going to go ahead and say that. Any point in here, you can pick it, name it, and then put the coordinates in the computer and it'll count it as correct.